Welcome back to another lecture. In this lecture, we're going to learn about Java Reflection API's entry point, the class object, from which we'll be able to start writing our reflection logic to look inside our application's classes and objects. We'll learn how to obtain that class object, and finally, we will review Java wildcards, which are not directly related to Java Reflection, but since we are going to make extensive use of them, it's a perfect point to have a quick refresher. So let's talk about the most important class in Java Reflection, which is also the entry point for anything we will do using Reflection in our programs. In Java, the class with the capital letter is the entry point for us to reflect on our application's code. An object of type class contains all the information about a given object's runtime type or a particular class in our application. That includes what methods and fields it contains, what classes it extends, what interfaces it implements, and much more. So how do we get an object of class? There are three main ways to do it. The first way to get the class object is using the getClass method of an object instance. For example, if we already have concrete objects of type string, of type car, which is a custom class we created, and an object of an existing class in the JDK like a hash map, we can call the getClass method on all three of them and get their respective runtime type represented by an object of type class. So in this case, we will get a class object that represents the Java string type, an object that represents our custom car class, and finally a class object representing the hashmap class. Notice that the last class object represents the hashmap class and not the map interface, since that is the actual runtime type of that variable. Notice that primitive types are not objects and don't inherit from the object class, so they don't have the getClass method and there's no way for us to get their type information from their variable instance. Now the second way to obtain a class object for a type is by appending the .class to the type name itself. That method is used when we don't have an instance of a particular class, but we still want to get class information of a particular type anyway. Using this method, we can actually get the type information for primitive types as well by appending the .class to their type name in the same way we did for a non-primitive Java class type. This is very important, as once we start inspecting method parameters, or class members for example, which can definitely be primitive types, we would need to be able to get the full type information for all the types in Java and not just classes. Finally, the third way for us to get the class object for a type in Java is using the static class.forName method. Using this method, we can dynamically look up any class in our class path using its fully qualified name. That includes Java built-in classes like a string, for example, as well as our own custom classes and interfaces. We can also get access to information about inner classes by using the $sign between the parent class and the inner class. And just like in the first method, we can't use the static forName method to get the class object of a primitive type, but this time, instead of a compilation error, we will get a runtime error. Also, as opposed to the first two methods, where we had the safety of a compile time check, using the third method to get the class object for a type, we are much more likely to make a mistake by mistyping the class name and get a runtime error in the form of a class not found exception. In fact, the class type name that we pass into the forName method may not even exist. So out of the three methods to get a class object of a type, this is the least safest one. But there are a few use cases where the forName method to find a class object of a type is our only option. One such use case is when the type we want to inspect or create an instance of at runtime is passed to us from a user-defined configuration file. Using this approach, users can change the application's behavior just by modifying an external text file with no need to change or recompile the source code. And using the static forName method, we can read the fully qualified class name from the config file and get the class object of that type at runtime. The second use case is when the class we want to reflect on is not even part of our project and does not exist when we compile the code. However, that class is added to the application's class path at runtime. This is very useful if we're building a library separately from the applications that will import and use it. Now, before we conclude, let's talk about that question mark that appears in between the angle brackets when we use the class type, which is called a Java wildcard. In Java generics, although a class like integer extends number and a class string implements char sequence, a list of number is not a superclass of a list of integer. And similarly, a list of type char sequence is not a superclass of a list of string. However, list question mark, which is also called a wildcard, is a supertype for a list of any generic type. Another way to say this is that list question mark is a superclass of list t for any generic parameter t. This kind of relationship is true for any generic type, including class, which is also generic. So using the class with a wildcard, we can describe a class object of any parameter type, as a class with a wildcard is a supertype for all of them. This is very useful when the compiler cannot know the exact generic type at compile time, like in the case where we use the forName method to get a class object of a type provided to us as a string. Another case where we would need to use the wildcard is when the generic parameter of the class is a generic type itself. Finally, using wildcards, we can put restrictions on types of classes that can be passed into a method, for example, by limiting the parameter type to only those that extend or implement a particular class or interface. Before we start applying everything we learned in practice, let's quickly summarize what we learned in this lecture. In this lecture, we'll learn about the gateway for us to use reflection, the class type. After that, we learned 3 ways to obtain the class object for any built-in or custom type we have in our application. The first one is using the getClass method on an existing object. The second one is by appending the .class to any class or primitive type we want to reflect on. And the third one is by using the static forName method to look up a class using its fully qualified name. Finally, we talked about Java wildcards, which we'll use extensively during the course, and in general is important to know about when using generics in Java. See you all soon in the next lecture.